Our presentation today is working from the ground up, identifying the vulnerabilities of cultural resources to climate change in the Midwest. Let's see here. So I want to first start off with a land acknowledgement. As a land-grant institution, the University of Illinois Urbana-Champaign has a responsibility to acknowledge the historical context in which it exists. In order to remind ourselves and our community, we begin by issuing this statement of the University of Illinois sits on the lands of the Peoria, Kaskaskia, Piankashaw, Wea, Miami, Mascoutin, Ottawa, Sauk, Misaki, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. And it's necessary for us to acknowledge these Native nations, for us to work with them as we move forward as an institution. And over the next 150 years, we will be a vibrant community inclusive of all our differences with Native peoples at the core of our efforts. So first, introduce ourselves. I'm Michael Abawasu. John and I are both with the Illinois State Archaeological Survey. I'm a geoarchaeologist with broad interests, but here in Illinois, working a lot on reconstructing ancient fire regimes. But then as a geoarchaeologist, I do a lot of studies of site formation processes. I'll let John pop in and introduce himself.
All right, I'm John Lambert. I'm also here at ISAS with Michael. I work in our GIS office doing a lot of spatial analysis, predictive modeling. I get to play with all our cool tech gizmos like our 3D scanner and drones and GPS units and things kind of along those lines.
Great. And so for our talk today, I looked through some of the past NAHAR presentations, and I've seen a few that focused on sort of the Midwest or the interior US, but they were all very sort of site-specific studies. So, but in this case, we're going to be thinking about statewide issues and of how cultural resources may be impacted by climate change. So I'm going to begin with an overview of how climate change is anticipated to affect the Midwest. And then I'll give an overview of what we might lose, what are some of the vulnerabilities. But I'm mostly the window dressing to John's work doing erosion, statewide erosion modeling and the potential vulnerabilities of archaeological sites to soil erosion. And we also will just talk about some general issues that we face in Illinois, and we look forward to hearing how researchers and advocates in other parts of the country have been figuring out how to move forward with climate-related cultural heritage management. So to begin, kind of overview of ISAS, who we are, and kind of what the unique situation we're in that I think has a lot of potential when it comes to climate work is we are the Illinois State Archaeological Survey, and we are one of 5 state scientific surveys under the umbrella of the Prairie Research Institute, which is an institute here at the University of Illinois. PRI is a big organization. I forget the total number, but I think we're up to, but there's 500 scientists. We have $65 million in research dollars, $65 million in research dollars. We used and, acquired and spent, I guess, in fiscal year 22. And we encompass a range of different, scientific related disciplines, all within this umbrella of doing applied science and science in the service of the state of Illinois, the region, and the nation writ large. ISAS is directed by Dr. Tim Pocketot. We have over 60 archaeologists, 16 of which have PhDs. So most of our work is compliance-based research, but you can see by that scale, we're pretty good size for doing compliance work, and we have more, PhDs on staff than most anthropology departments at all, unless not even thinking of archaeologists in anthropology departments. So, it's a pretty unique setting we have here. And so, our role, as a state scientific survey is to, meet a lot of needs for meet archaeology and heritage needs across the state. So, we, are out collecting new data and curating information to provide data and for archaeological communities and the community writ large. Dr. Pocketot is also the state archaeologist. So, we do a lot of efforts, thinking about planning, and then this is, and how do we as, provide, information for the state and how can we provide planning documents to get ahead of issues. And that's kind of where our climate talk will get into today. In terms of new technologies, John alluded to, already said that he does a lot of work applying remote sensing. Our affiliation with the university allows us to leverage a lot of campus resources. I do a lot of, for my soil micromorphology work, I've been being able to access a lot of really great resources to facilitate this work and then find ways to apply it in sort of compliance-based research. And in terms of education and training, we're able to do a lot of public outreach. We have a tribal speaker series, which is starting up next week for our spring series. So check out our ISAS website for more of that. And of course, student employment and training in our collaborations with the university. So with climate change being, an all hands on deck problem for society, here at the Prairie Research Institute, we're now really trying to work through how we bring together all the different elements across our different surveys, to meet the challenges that climate change faces. And so ISAS is in there too. The state recognizes, or at least as researchers, we recognize the challenges that we have in cultural heritage and preservation in the face of climate change, and that how this is an issue that touches upon health, economy, ecosystems, and has environmental justice components as well. So one of the, as I go through kind of the overview for this work and where we are in the state of Illinois, you'll see that I'll be referencing our collaborations, some both developed and some nascent, with the other surveys to truly address these problems, and in a lot of ways for us to be the bug in the ear for other researchers to start factoring in the work that we do as archaeologists and the concerns that we have. So I know from Nahar, a lot of folks are working more in coastal settings. So the question is, how do we turn to what are the issues of climate change here in the interior? And so very, as bare bones as possible here, based on historical averages, we're already seeing a 1 to 2 degree Fahrenheit change in average daily temperature. And over the last, I believe, 30 years was they used in this climate assessment report. And forecasts speak to temperature increases from 4 to 14 degrees Fahrenheit by the end of the century. The precipitation has already increased 5 to 20%, and higher magnitude events are increased by over 40% from historical averages. And we expect to see that increase as well. And changes to precipitation, both in the total precipitation and the magnitude of it, is really, as you'll see, a big driver for impacts to cultural resources. Now, when this climate assessment was put out just 2 years ago now, all the other surveys were involved in it, but it got into not just how climate will be changing, but how it will be impacting different segments of populations and industries and agriculture across the state. Cultural resources, was left out, but in that discussion. But the great thing about PRI is I have an office down the hall from the state climatologist, so I could poke my head in and go, wait a second, what about us, and get those discussions going. But in terms of some perspective on what climate change may feel like, at least temperature-wise, I'm sure hopefully you all have seen these kinds of maps. This one's by University of Maryland's research project, projecting what climate will feel like in 60 years. And I have us here in Champaign, Illinois, and will feel like northeastern Arkansas, more or less, in the future here, which is, not good, but there are worse circumstances than that, which we'll also get into a little bit later. So in terms of how things like changing precipitation, I should also I left out that there's the rapid onset droughts, flash droughts also come in tandem with these higher precipitation events, which also presents challenges. But first, I'm going to talk about shoreline erosion of the Great Lakes. People don't think of the Midwest and shorelines, but there's quite a bit of it. one of your tidbits for the day, of course, is Michigan has over 3,000 miles of shoreline, more than Maryland, almost as much as Texas. Illinois only has 61 miles of shoreline. However, we're already experiencing a renewed period of shoreline erosion. And while it's incredibly complex and not fully understood, the potential for higher precipitation may very well lead to, and warmer temperatures would lead to increased, higher lake levels. Our Illinois State Geological Survey has already been doing quite a bit of really interesting work of understanding the processes of shoreline erosion and sediment transport in nearshore zones. And in that process, they've been identifying foundations and traces of earlier periods of shoreline erosion. In those traces in homes and neighborhoods that were eroded away, over just about over 50 years ago now, in northern Illinois. So this has been a circumstance where we at ISAS have been able to start working with our geological survey and working with state agencies to start identifying, doing stakeholder meetings to identify, what are the cultural resources at risk in shoreline zones, and what are the concerns amongst professionals, and shoreline erosion and the potential for it to be accelerated is a major concern, and especially in our urban areas and urban communities. In Chicago, it has the effect similar to what we're talking about, or should be familiar to what people are talking about and thinking about in coastal areas. The main driver of impacts to cultural resources, to large-scale impacts, is flooding. And what we're looking at on our left here is the map of the extent of flooding of the most recent large-scale flooding event in 2019. This New York Times title of this summary article puts it into perspective as the slow motion disaster. Whereas when I'm coming from the South, coming from Texas, and thinking about hurricanes, these are relatively rapid, significant disasters and events that hit communities. Whereas here in the Midwest, these events sort of accumulate over time and they persist. The photo on the right is Davenport, Iowa, the Quad Cities. They were hit really hard with this flooding, flooding a lot of urban historical areas and shutting down infrastructure. One of their bridges, one of the main interstate highway that goes through Davenport, was closed for 2 or 3 months due to the scale of this flooding. I mean, life goes on. I looked really closely at this picture, and I realized that there are players on that baseball diamond, and you see the cars lined up. And so cities like Davenport have started rezoning their waterfront or the riverfront downtowns to try to better accommodate flooding. But this problem isn't going away, and it's becoming more frequent. If you look into just the last 30 years, of our top 10 floods or top 7 floods, most have happened in just less than the last 30 years or so. And this flood risk is changing. We have, of course, we can consult FEMA flood hazard areas, but with the increased frequency of flooding and potentially higher magnitudes, our priors may not serve us well. So I've been in discussions, and John as well, with our Illinois State Water Survey, who produce a lot of these county-specific or watershed-specific maps, to start thinking through, okay, what happens, how may we start projecting out changes in areas that are vulnerable to flooding. And they've recently gotten access, or getting access, to the First Street Foundation's new flood projections to incorporate into their own work. And so this is a cool opportunity we have here at ISAS, is we can start then working with them to identify, overlay our site distribution models or maps and some of the modeling work John does with projections of where the risks of flood may be increasing. Soil erosion. Out of the river valleys and speaking in the uplands, soil erosion is a major concern in our state because it's so heavily agricultural dependent. We're seeing soil erosion increasing across the state at the same time that we're seeing, higher incidences of high magnitude rain events, across agricultural areas. And as this graphic here also shows, we're seeing less money going towards soil conservation. As archaeologists, this is where we've seen some of the most immediate impacts to cultural sites. And this is the kind of work that John will be getting into directly and starting to think through at the statewide level, just how bad is erosion and how vulnerable might archaeological sites be. We also are starting to think long term about climate migrants, as unpleasant as having a climate similar to Northeast Arkansas might sound. It could be a lot worse. So I'm sure people have seen in the news the articles of people identifying the Midwest, particularly the upper Midwest, as a great place to move to. This map of the U.S. shows projections of economic damage by unmitigated climate change, and you see the northern tier, may actually, see growth. Here in the state of Illinois, that could present some challenges. Certainly, would present challenges for cultural resources. At the simplest level, I moved here from Texas 3.5 years ago, and in Texas, I knew their SHPO office had about 5 to 7 reviewers. Actively reviewing projects, undertakings across the state. Again, the state's bigger. It's just three times as big by population as Illinois. Come here, and there's one full-time reviewer and there are 2 reviewers who handle different aspects, but for the entire state. So if Illinois does hit a period of rapid growth, that's going to impact significantly, how we think about how we manage resources across the state. So let's think about what we might lose in terms of cultural resources. First off, a lot of the cultural sites, the pre-contact cultural sites, are in these fields. This is a soybean field outside of Bloomington, Illinois, not too far away from here in Champaign. You're looking at 800 to 1,000-year-old house with pit features surrounding it. All just these are the classic features that extend down into the subsoil, then are left preserved. And so, as we know, we have a tremendous archaeological record here in the state. So when we think about flooding, the real issue, the most damaging types of flooding are when levees fail, and those lead to significant erosion in floodplain settings and potentially in upland settings that can destroy highly erodible pre-contact sites, but it can also significantly affect historic communities. We've already seen here in Illinois we've seen managed retreat from the 1993 flooding. We have the case study of Valmeyer, Illinois, small farming communities south of St. Louis on the Illinois side of the river. Already went through the process of rebuilding in an uplands. And there's all kinds of issues that were related to the economic justice of wealthier people able to access the funds and have the capital to secure that move, whereas others weren't. And of course, we think just the fabric of historical resources in these communities being damaged. And we'll talk a bit more about kind of where we're just at the beginning stages of dealing with that in Illinois. But when we think about soil erosion, we can just go straight away to the premier pre-contact site in Illinois of Cahokia. In terms of the types of research being done at Cahokia, there's a tremendous amount of research focused on climate in the environment through time and how that relates to the cultural history of Cahokia. Director Tim Pockettide has a book that just came out looking at climate-related issues as a factor. We have a geoarchaeologist, Dr. Caitlin Rankin, who's done a lot of this kind of work in her dissertation work and continues to work in this region. So, when you think of Cahokia, we have this UNESCO site. You've walked the 154 steps up 100 feet to the top of this mound. And this is, certainly in one of these places that as archaeologists, we all have to go visit, and all Americans really should visit this site. But if you approach this from another angle, you start realizing that there's a lot of challenges in the management of Cahokia, which everyone in this part of the world knows about, but was new to me moving here. But if you have this LiDAR view looking down upon Cahokia, while the approach from the south up those stairs looks nice, you can see the range of different scars and erosive features on the east, north, and west sides of the mound. Now, this is nothing new. The earliest maps and drawings of Monk's Mound here at Cahokia showed lobes of erosion. But this is a problem that's not going away. Some of the earliest salvage excavations in the 70s were of some of these lobes, and since the 1980s, basically every generation of resource managers has to confront this problem of this site eroding, of how we're losing this site. There have been engineering studies as early as the 80s on understanding the problem. There have been geomorphology studies along the way, and there have been repeated efforts to shore up effectively Monk's Mound. However, it's still eroding, and essentially the problem is that the clays underlying Monk's Mound, as well as some of the constructed materials, are impermeable clays that then, after really high magnitude rainfall events, lead to these perched water tables. And then you get slumping and fans and this unique, slump toe roll, this little, right on the margin here of the mound, that are still actively happening. So this one, the photo here is from summer 2022. This pipe sticking out is an old monitoring well that was put in. Has been sheared. It's not a good, it's at like a 45-degree angle in this photo. And I wasn't out there after a big rain, but apparently you can, colleagues have said you can actually hear the earth as the soil is creeping and moving along this toe. It's a big problem. You can see just the fan on the east side of it. So with projections of more frequent high magnitude precipitation events, it's a reality that this problem, even though there have been mitigating efforts, piling up of fill dirt, from other DOT projects have been used to shore up parts of the mound. Various fabrics have been put down, but still, with higher magnitude rainfall events happening more frequently, we don't expect this problem going away. And so as a case study, this seems to be something we'll be happy to address with mounded sites and other sites across the state. So in a sense, what has been done, right? So after some of the really large events, like in 1993, and I believe, and also 2008, NPS, Emergency Supplemental Historic Preservation Funds, or their earlier versions of that, have been able to release funds for Section 106 and 110 surveys, primarily on federal land. So those kinds of surveys do happen, but of course those things are happening, after the event, right? After there's been loss. Our state certified local government program has started hazard mitigation planning with local historic preservation districts. But this is just getting off the ground. And as we know, if you don't have a plan in place before an event occurs, it's much harder to be able to, to have the proposal ready to access funds for support. It's our historic preservation. And there are some examples now where agencies are starting to be a bit more proactive about thinking through when you have an overlap between cultural resources that may be vulnerable to accelerator of erosion that are also near infrastructure. How can you sort of find a win-win situation of sorts? And I've heard examples from the Iowa DOT identifying cultural sites that are in risk of being eroded away. This is a Dixon site, an Oneota site in Iowa. And so in advance of rip-wrapping and armoring that the stream channel, they recognized that there was an archaeological site, potentially an archaeological site in between the infrastructure and the bank. And so they did some archaeological mitigation in the place of this to both where they were going to put their infrastructure. So to help armor it and also protect aspects of the site. So we're seeing some of that, but again, we're sort of just in the early stages of linking the potential loss of sites to the accelerated vulnerabilities that we're starting to see. So we'll switch it over here to John. Just want to say, so what can we do? And John's example is great here, but a lot of what we're doing here at ISAS is just trying to get a seat at the table, is working with our other scientific partners to help them understand the nature of the problem. And when we go in on projects with the Geological Survey or looking at the resources the Water Survey has, see how we can leverage those resources to really start making some headway in terms of identifying the problems, getting information out to communities through presentations with things like our extension agencies, and ideally finding funding sources to help with this stuff, which I hope some of you other folks can speak to. So with that, take it away, John.
All right, so let's switch over the screen share here. Michael and I are actually sitting like 30 feet down the hall from each other, so we were joking that I should actually just run in and sit in his chair. Okay, so can everybody see my screen now?
Yes.
Okay, cool. So yeah, as Michael kind of outlined, we're in sort of an interesting position in the Midwest where we don't have, at least to the same extent, the sort of dramatic, headline capturing effects of climate change, accelerated erosion that we do in places like the coastal, the eastern seaboard. And that's good and bad. I mean, it's good because we have a little more time to get out in front of the problem, at least as far as it relates to impacts to cultural resources. But as Michael kind of alluded to as well, there are aspects of that situation that make it harder to get a seat at the table just because it's not such a dramatic visual sort of impact that people can see. So part of what we wanted to do at ISAS is actually try and get a better handle on where are we seeing topsoil erosion now, and how is that likely to change in the near future? And then how can we compare that to things like the distribution of previously recorded sites, or the probability of running into sites in places in the future that may or may not have actually been surveyed. So we've started something that we're calling the Illinois Climate Change Modeling Initiative. So this is mainly focused on erosion and its potential impacts to archaeology, but that's not the only application. We've talked to people at the State Water Survey, the State Geologic Survey, Natural History. We're starting to put some feelers out to different agricultural focused organizations in the state, people that deal with, say, things like groundwater or water quality monitoring. Obviously, there are a lot of stakeholders that care about soil erosion besides just cultural resources. So we're hoping that's some avenues for kind of future collaboration with other groups. It's a model for the whole state. So that comes with kind of a set of constraints that you might not run into with modeling a smaller study area. So one is just, what data can you use? You're limited to data sets that obviously cover your whole state. They have to be available at kind of a suitable resolution that is useful, but isn't overwhelming. And so at least for now, we're kind of, with this first version of the topsoil erosion model, just looking at current and sort of recent historical data. So really what this is a model of what we've already lost or what we're going to lose soon. Of course, as archaeologists, what we really want to know is how much time is left in the hourglass for sites in different parts of the state. So that's going to kind of be part 2 of this model. So spoiler alert, here's the map with the results for the erosion model. It relies on this basically set of equations called Russell. It's the revised universal soil loss equation. And as Michael kind of got at, topsoil erosion is really a totally different process than erosion and damage due to flooding. So yeah, this map does show floodplain areas, but it doesn't really apply. This is mostly a model of upland soil erosion due to sheet wash and rill formation. This Russell model is frequently used in agriculture, but generally on pretty small scales. So most researchers are looking at single test plots, think the level of one farm, or people have applied it to single archaeological sites. And usually that's to look at, what happens to the amount of soil loss we'd predict if we say add a stone wall along the margin of a field, or we start terracing. And so there are some modifications you have to make to the model, but there's some ways that you can adapt it to apply to much larger areas. So the original versions are using things like the energy of individual raindrops in, like the impact velocity on like millimeters of soil area. So there are some changes we have to make to adapt this to the level of a whole state. So what the model is really predicting, and like I said, kind of take this with a grain of salt since some of these equations have to be modified a bit, but it's tons per hectare per year of soil loss. Now, when you change some of the things, it's a little unclear what your numbers actually mean, but just think of it as more or less likely to erode. So this is just kind of an erosion susceptibility index. And one of our strengths actually in the Midwest is historical climate data. We have really good data for things like precipitation. One of the really helpful resources is the Midwest Regional Climate Center. They have, there's hundreds and hundreds, really thousands of precipitation monitoring stations all over the Midwest. You can get daily, weekly, monthly, whatever time slice you want. So for this model, we used the last 10 years of monthly precipitation data. And when we're trying to think about how might changes in precipitation affect the vulnerability of, say, particular spots on the landscape to erosion, there's a couple things that matter. It's not just the amount of precipitation, it's also how concentrated it is in individual events. So the model takes kind of both of those things into account. So more precipitation leads to more erosion, but also how peaky it is, how concentrated it is in particular slices of time. So we're using monthly data for the last 10 years. You also have to take into account how susceptible different soil types are to erosion to begin with. We have really good soil data from USDA. A lot of that has been processed by Esri. One thing that, again, kind of works in our favor, but also makes some of this modeling challenging is that Illinois is pretty boring in terms of topography for the most part. So I know this map doesn't look like a lot, but this is the effect of slope length on erosion. So it's not just the length of a slope, it also takes into account flow accumulation of water as it's moving down a slope. So just think the longer that water has to travel down a slope, the more velocity it's going to pick up and the more dirt it can move. So Illinois is mostly pretty flat. It's featureless till plains for the most part, with some steep-sided river valleys and kind of some rugged areas in different parts of the state. So slope length matters, but slope steepness obviously matters quite a bit too, but not in a linear way. So the effective slope really ramps up at kind of lower values and it tapers off again, kind of once you start to approach vertical, it doesn't matter that much more. So this actually kind of highlights the topography of Illinois a bit better. So we've got really rugged areas in the southern tip of the state. There's actually some national forest, believe it or not, in Illinois down there. The kind of the lower Illinois River Valley, and then up here in the unglaciated areas in the northwest corner of the state. Outside that, so Champaign is right here to kind of give you an idea of where we're sitting, pretty darn flat. And another thing that matters quite a bit, and this is something that is a really active area of research in a lot of places. What's the effect of different kinds of ground cover on susceptibility to erosion? There's some really good studies out there in different places on essentially you're looking at the amount of erosion that's mitigated by different kinds of crop or surface cover. So for example, row crops like corn and beans, that does offer some surface cover and protection from topsoil erosion, but not a whole lot. Not nearly as much as say something like a forested area that's never been cultivated. It's like I said, it's an active area of research. A lot of this we're relying on remote sensing data. So it's machine learning models based on satellite imagery, aerial photography, things like that. And different areas are classified in different land uses. The data is pretty good, but there are definitely some warts. And this is an area I expect to get better in the future as those models improve. And obviously, this is something that's going to change going into the future. So I'll talk about that in a minute, but we really have to think about how is land use going to change as climate change intensifies? What's the effect on, say, agriculture or where people decide to develop? And unfortunately, one thing that we weren't able to include in the model kind of at this early stage is the effect of different soil conservation practices. We know it's happening. It's actually fairly widespread across Illinois. I think it's a little over 75% of Illinois is actually farmland. And we know that on about half of it, people are using some kind of soil conservation practice. So whether that's no-till agriculture, things like grass buffers along the edges of field or cover crops, it's happening. We know there are programs to incentivize those mitigated measures in the state. And actually the state just passed or is likely to about pass, I think, a big increase in funding for those measures. But we don't know where that's happening. There's no data on, what particular plots or fields are using something like low or no-till agriculture. So that's definitely going to be an area where we need to get some good data moving into the future. So how does that match up with what we know about the archaeological record? One of the real strengths of Illinois is that we have more than 100 years of archaeological data that people have gathered in the state. So we have a little over 69,000 previously recorded archaeological sites. 56,000 and change of those have pre-contact components, and a little over 19,000 have historic components. If you compare that to the results from the erosion model, you can see that there are some parts of the state that are really particularly vulnerable. So think about, places like Northwest Illinois or Western Illinois, where you have steep, intensively farmed slopes where, holy moly, look at the lower Illinois River Valley here. It's jam packed with sites and it's really high potential for erosion in a lot of those places. 80% of pre-contact sites that we already know about are in high erosion potential areas, and 82% of historic sites. So some of that may have to do with discovery bias. So we know you're more likely to see sites and discover material in places where you can actually see it. So in some modeling we've done before, probability of discovery is actually positively correlated with kind of moderate levels of erosion. So that makes sense, right? But it's also just has to do with where these sites are located. So we potentially stand to lose a lot in the near future. And I should say farming isn't the only source of surface erosion in Illinois, but it's one of the main drivers. We're also doing some work to model potential site probability. So this is a model that we've actually already released. We have a free public web viewer that anybody can go and check out. It's available to the public, and people can zoom in down to about the level of a neighborhood before the model isn't visible. And then we have full resolution versions that are available only to professional archaeologists. But this just predicts the probability of encountering an archaeological site. And I should say it's only pre-contact archaeological sites in this model. In any 90 by 90 meter pixel in the state. So that's about 2 acres. So it uses the location of known archaeological sites and an equal number of randomly selected non-site locations and a whole bunch of environmental and geophysical variables. And at least so far in our testing, the results are really good. Only about 27% of the state is classified as high probability, but it hits over 70% of test sites. And there's not a bad amount of overlap, unfortunately, between high archaeological probability and high erosion potential. So a little over half of high probability areas are also high erosion potential. So we're starting to think through what does that mean in terms of the way that ISAS and other organizations in Illinois should prioritize resources for where do we go out and try and target for additional survey? Where do we make sure we do more testing? Where might we need to put in place some more topsoil erosion measures that like cut down some of the risk to sites? We're also starting to think through kind of the triple whammy of places that are high probability, high erosion potential, and where very little survey has been conducted in the past. So places where we don't know a lot and are likely to lose sites in the really near future. So what do we need to move forward? Like I said, kind of the first version of the model is just based on current and historical data. It's telling us what have we already lost or what are we going to lose kind of under current conditions. But we really don't know much about the actual rate of erosion that's occurring right now. Like I said, what we really want to know is, does a site in this location have 20 years left? Does it have 50 years left, or is it going to erode in the next year? A lot of that is obviously contingent upon different climate change scenarios. So what do we need? The big first one is we need good estimates of historic and current erosion rates. So what's actually happening now? There's a few ways we can get at that. There's some really interesting studies that look at places on the landscape that have never been cultivated. You know, what are erosion rates like going back into, say, the late Pleistocene and early Holocene, and how do those compare to adjacent areas that are cultivated? People are using things like just really direct measures of topsoil thickness or different isotopic things like different beryllium isotopes, and those respond differently to different rates of topsoil erosion. We also want to set up some monitoring at archaeological sites. And I'll talk about that in a second. But another really kind of interesting possible collaboration is this project called the Illinois Centennial Soil Project. So one of the organizations on campus here, they were decommissioning an old storage barn and walked inside just to see what they had before it got torn down. And this is what it looked like. It looks like total chaos, but what you're looking at on the shelf there, those are actually all individual soil samples that some of them go back 100 years or more. They've got really good location data, actually. And this research group has picked basically the best 450 where they want to go back out and resample these locations. The original samples almost all come with either original soil profile drawings or measurements of topsoil depth. So they're going to go back out and resample these same locations and generate a really unique data set that could speak to historical rates of erosion over the last 10 decades. That's not the only thing they're looking at. They're also interested in, say, topsoil nutrients and effects on water quality. But this is one kind of potential avenue we're looking at. We need better data on the distribution of conservation practices, and then the effects of climate change on things like vegetation cover. And it matters. It matters a lot. Depending on whose data you look at, topsoil erosion in the Midwest is expected to increase 40 to 65% in the next few decades. So the big thing that we're going to go out and try and do, believe it or not many people are actually out there collecting data on erosion rates in Illinois. Like real actual measured rates of erosion that we would need to build a more sophisticated statistical model of erosion. So if it doesn't exist, we're going to try and generate the data ourselves. We're initiating right now kind of a pilot project where we want to monitor topsoil erosion at kind of a small set of archaeological sites in different settings around the state. So it's what you can see on this map on the right. So the red dots are all of our field stations around the state. We've got 5 of them. And then the yellow dots are all places where there are GPS corrected geodetic survey benchmarks. So the idea is that we want to pick archaeological sites that are within a certain distance of a benchmark so we can set up a survey grade GPS and at least cut out kind of one potential source of error in our elevation measurements. We want to use drone-based photogrammetry, or possibly in the near future, LiDAR-based drone work. And it's a really challenging technical problem. The erosion rates that we're trying to measure on an annual basis are almost universally less than a centimeter per year, which is really approaching the measurement error of our equipment. So that's going to be our first technical challenge, is can we measure annual change that's basically sub-centimeter? At least in kind of some initial testing and other studies people have done, flying lower when you fly photogrammetry using things like GPS corrected benchmarks, it can get you close, but there are some methodological problems that we're going to need to work out in the future. So here's just kind of a view on a smaller area near one of our field stations. And you can see there's actually quite a few sites that land in those yellow circles. I think it's something like 1,300 across the state. So that's where we are right now, is choosing the best candidate sites where we might actually set up this erosion monitoring pilot program. Like Michael alluded to, surface erosion isn't the only potential impact to the archaeological record that might be driven by climate change. Development is a big one that we're trying to start to get a handle on and make some predictions about. The biggest data set that we've been able to lay our hands on right now, they're stormwater discharge permits. So anytime that a ground disturbing activity is going to disturb more than an acre, people have to apply for one of these stormwater discharge permits. And we were able to get these data from the Illinois EPA. They actually asked us to submit a FOIA request to get the data, which was a little strange. It's kind of, we can't send them to you, but if you submit a FOIA request, we'll give them to you, like wink, wink. But it's a really juicy data set. There's about 35,000 permit applications that have been submitted over the last roughly 30 years. And the map here is just summarized by zip code. And there's not a lot of surprises, right? There's been a lot of development around large to kind of medium-sized cities. A lot of that is expanding out into kind of surrounding areas that previously haven't seen development. So that's something we really want to keep an eye on and maybe try and forecast into the future a little bit. How might those patterns change as land use or farming practices or the influx of people into the state changes over time due to climate change. Okay. So Michael, you want to kind of wrap up here?
Sure, but feel free to jump in. So yeah, so here's that was our overview of where things stand for us, at least, in thinking through these issues here in the Midwest. A challenge. So something that I hope that we can bring up in the discussion here from you all is, for some of these projects that we're working on, how do they compare to some of the projects in your state or your area of expertise? And the age-old thing that goes back to the song and the critique of capitalism is, as much as we want to know we're doing good work and want to do good work, we have to find the funding to do it, right? And I'm sure other people have identified the fundamental flaw in our funding situations is that quite often disaster-related funding is coming after the disaster, and then states like Georgia, and I know Texas, they're using some of their funds from recent hurricanes to develop predictive models. But curious to think how people find solutions to getting ahead of climate-related issues, which I know is tough. As I hope we've demonstrated the importance of collaborations to you all. How critical it is that we've been finding to work with other scientists, and we're curious to hear other examples of how folks have been doing this as well, both the good and the bad potentially. There's times when we reach folks and they understand what we're saying and it's a direct connection, of course, other times less so. And of course, and since we have some Florida folks, there's long, you all have, been doing this for a while now, and public advocacy for climate-related issues to heritage. And in a lot of ways, we're just kind of getting going here. Just sort of, we're at the point where we occasionally get asked to present at meetings and things, but hasn't really, there hasn't been a great hook for cultural resources into climate-related work. So we look forward to hearing discussions about that as well.
I mean, I think one of our big, as you kind of alluded to, I think one of our big hooks is going to be how the products we generate, like a predictive model of erosion potential, how do those benefit other stakeholders like agricultural concerns or developers? That's not our main aim, but there are a lot of potential consumers of those products. And one of the surprising things for me getting this research going has been talking to people at the State Water Survey or Illinois EPA or USDA, and they're like, wow, that's really interesting. Nobody's ever done that. Even though something like a model of topsoil erosion, it has really real economic effects on something like agriculture. So that's going to be one of our kind of main avenues to try and get hooked into some of these things, like funding to mitigate impacts to agriculture or programs that monitor water quality because of dissolved sediment in waterways. So a lot of people are looking at similar problems, but often from the other end. We want to know, where is the dirt that's eroding coming from? A lot of other groups are looking at, where is the dirt that's eroding going? Where does it end up in waterways, for example? So a lot of these discussions are ongoing, but like Michael said, they're kind of in their beginning stages right now.